Okay, these are the 8.1 sample spaces and probability notes. So first let's start with a little bit of vocabulary. So a probability experiment is an action or a trial that has varying results. So like flipping a coin or drawing a card or spinning a spinner, the results vary. The possible results are called outcomes. So like if you flip a coin, you could have heads or you could have tails. Those are the outcomes. The event is a collection of one or more outcomes. So for example, if we were rolling a dice and we said like rolling an even number, that can include 2, 4, and 6. So that's multiple outcomes in one event because we said rolling an even number. And then a sample space is the set of all possible outcomes. So like if you're rolling a coin, rolling a die, the possible outcomes are that you could roll a 1, 2, 3, 4, 5, 6. And that's the sample space, is everything that can happen. Okay, pause the video if you need to finish writing those. Example 1 says, you flip a coin and roll a 6-sided die. How many possible outcomes are in the sample space? List the possible outcomes. Okay, so I would suggest making kind of a tree. So on the coin, you can have a heads or you can have a tails. Those are the two possible outcomes. And then when you roll the die, there can be a 1, a 2, a 3, a 4, a 5, or a 6. Now, that can happen if you flip a heads first, but then if you flip the tails first, there can also be a 1, a 2, a 3, a 4, a 5, or a 6. So you can kind of follow this along to list out the possible outcomes. So you can be like, okay, I have a heads and a 1, a heads and a 2, a heads and a 3, and so on. So when we list them off, I'm just going to use H for heads and T for tails. So a heads with a 1, a heads with a 2, a heads with a 3, heads with a 4, a heads with a 5, heads with a 6, and a tails with a 1, a tails with a 2, tails 3, tails 4, tails 5, tails 6. Those are all the possible outcomes. And so by making the little kind of tree, it helps me organize my results. And it's a really good thing to do when you have like something more complicated that you're trying to figure out what can happen. Okay, theoretical probability is what can happen just in theory. So like flipping the coin. We're going to learn about what happens when you actually try an experiment and you physically flip a coin and keep track of the results. So this is just mathematically what the probability is. And so how you find it is you find the number of favorable outcomes. So what that means is like if you want to have a head and an even, then you count up how many complete that with a head and an even, and then you divide it by the total number of outcomes. Okay, so example 2 is a student taking a quiz randomly guesses the answers to 4 true-false questions. What is the probability of the student guessing exactly 2 correct answers? So what you do first is you figure out the outcomes. So let's think about how many ways that they can guess certain numbers correct. Okay, and so it is 4 true-false questions. So they could get, if they did 0 correct, that means they would get each one incorrect. I'm going to put I for incorrect. Okay, if we want to know how many ways they can get exactly one question correct, well, they could get question 1 correct and the others wrong. They could get question 2 correct, but all the others wrong. They could get, sorry, too many there. They could get question 3 correct, but miss all the others. And they could miss the first 3 and get number 4 right. So that means that right there are 4 different ways they could do that. Now, how many different ways they could get 2 questions correct? Well, they could get question 1 and 2 correct, and the other's wrong. They could get 1 and 3 correct, and the other's wrong. Okay, they could get number 1 and number 4 correct. And then that's all the ways with number 1 correct, but they could also get, let's see, they could get number 2 and 3 correct. And they could get number 2 and 4 correct. And then last but not least, they could get 3 and 4 correct. So I think that's all the ways, 1, 2, 3, 4, 5, 6. Okay, and then let's look at how many ways they could get 3 questions correct. Okay, well, if they got the first 3 correct and the last one wrong, or they could get, so we're looking for one, missing just 1, getting 3 correct. So they could miss the 4th one, the 3rd one, they could miss the 2nd one, they could miss the 1st one. It's kind of the opposite of getting 1 correct, it's getting 3 correct. And then to get 4 correct, there's only one way they could do that, and that's getting every single question right. So if you count up, this is all the outcomes. So the sample space is counting them up. So there is 1 outcome here, 4 here, there were 6 here, 4 here, and 1 down here. So the sample space is what we just did, is all of this, all the ways it can happen, the number of outcomes total is 1 plus 4 plus 6 plus 4 plus 1, right? And so that is, let's see here, 16 outcomes. The number of favorable outcomes, meaning what we want to happen, which we wanted exactly 2 correct, so that's this row, and that was 6. And so to find the theoretical probability, which means what could happen in theory, not what happened in real life, you do the favorable outcomes out of the total outcomes, which is 3 out of 8. And sometimes they'll want it as a percent. So if you do 3 out of 8, you get 0.375, which you can times by 100 or move the decimal place. It's 37.5% is the chances that they get exactly 2 correct when just guessing. Okay, so when 2 6-sided dice are rolled, there are 36 possible outcomes as shown. I think this chart is really good to keep kind of handy when you're doing your homework, because it's nice just to look at and figure it out. So these are all the possible ways. So it wants to know the sum is not 6. So when you're doing not, there's kind of a probability of something not happening. So of an event, I'm going to call it event A. So not A. How you find the probability of an event happening is not happening is you take 1 minus the probability it does happen. And so, and a symbol you're going to see for not A is like a line over the top. This means not A. So like if the probability of something happening is 30%, then the probability of it not happening is 70%. So let's see how we do this. So if we find the probability that the sum is 6 is a lot easier than finding like the probability it's not 6. It's just easier to count up. So find the probability the sum is 6. So looking at this chart, we're looking for ones that add up to 6. So that's like this one, 5 and 1, and then 4 and 2, 3 and 3, 2 and 4, 5 and 1. So that's 1, 2, 3, 4, 5. That's 5 out of 36 outcomes. So if you want to find the probability the sum is not 6, then you do 1 minus 5 over 36, which that's like 36 over 36. When you subtract 5 over 36, you're left with 31 over 36, which you could also do as a decimal or a percentage, just depending on what they want. It would be that or 86.1%. It just depends on how they want it. Okay, if we want the sum is less than or equal to 9, all right, if we want the probability that the sum is less than or equal to 9. It would actually be easier to find the probability that the sum is greater than 9, because that is the opposite of what's actually like what they're asking for. They want less than or equal, so bigger is the opposite. So if we find the opposite, then we can use the how you find not, and we can do that. So the probability the sum is greater than 9. Let's see. That happens. I'm looking for sums greater than 9. All of these are 10, 11, and 12. So 1, 2, 3, 4, 5, 6. That happened 6 times. That's 6 out of 36. All right, and so if you want to find probably the sum is less than or equal to 9, that's everything but the 6 out of 36. So that leaves 30 out of 36, which is the same as 5/6. All right, and as a decimal, if they do that, that is 0.833. If you do 5 divided by 6, or 83.3%. Okay, you did problems like this in geometry. It's kind of geometrical probability because it deals with area. It says you throw a dart at a board shown, and your dart is equally likely to hit any point inside the square board. Are you more likely to get 10 points or 0 points? Okay, so to get 10 points means you're hitting that center circle. So this circle right here. And so if we find the area of the 10-point circle, then we're going to do pi r squared, and the radius of that is 3. So pi times 3 squared, which is just 9 pi. Okay, and now if you want to find the probability of hitting 10 points, then you need the area of the board, because that's the total area that you can possibly hit. So it's the total options. And the board is a square. If you notice, this says this is 3, 3, and 3. So this distance right here is 9. That tells me the side is 18. And since this side is the same because the circle fits in there, this area of the board is 18 times 18, which is 324. So the probability of 10 points is doing 9 pi over 324, which you type that in a calculator and you get 0.087. So a little under 9% chance. So then it says, what's the probability of 0 points? Okay, that's a lot harder to find. So probability of 0 points. 0 points is, I'm going to draw a rough sketch here. 0 points is just this area out here. So to find 0 points, you need to take the square minus the large circle, and that will leave you with that little leftover area. So to find 0 points, the square we know is 324. The large circle has a diameter of 9, and so that's going to be pi times 9 squared. So the 0 points is going to be 324 minus pi times 9 squared is 81 pi. And that's your chance of getting the 0 points out of the total board. Remember, the total board we already found was 324. So you put that in a calculator, and the probability of 0 points is 0.215. All right, and so that's significantly bigger than the 0.087. So you are more likely to hit 0 points than 10 points. All right, experimental probability is different than theoretical probability. What experimental probability is the chance that something happens in an actual experiment. So like not just mathematically how it might happen, it is like if you do an actual experiment where you actually flip a coin, what the probability turns out to be. So it's the probability with results from a real life experiment. It's like you physically flip a coin and you write down what happened. Okay, so this one is saying, hey, someone actually did this. Each section of the spinner has the same area. So this is the spinner, and then the chart shows you what actually happened when the spinner was spun 20 times. They kept track of the results. So which color is the experimental probability of stopping on the color the same as the theoretical probability? Okay, if these are all the same size, then what that tells me is that in theory, all right, each one should happen 0.25% of the time, or sorry, not percent, 0.25 amount of the time, 25%, because they're all equal and there's 4 of them. So each color has a 1 out of 4 chance of landing on, which is 0.25. Now, for this table, go ahead and find out. This was out of 20. So if you take 5 out of 20, 9 out of 20, 3 out of 20, and 3 out of 20, you're finding out what actually happened in this problem, like when they physically spun it. So I went ahead real quick and wrote down the probabilities right here. So the only one that matches the 0.25 is the